What is going on, guys? Welcome to your 29th video, and in this video I want to talk to you guys about a different, more interesting type of energy, that is kinetic energy. But first, let's go ahead and recap. In the last video, or in the last couple probably, I said that potential energy was basically stored energy. The energy stored in objects when they aren't moving, such as in the case when the apple was hanging from the tree. It was just sitting there doing nothing, but it had the potential to make some energy. So again, potential energy is stored in objects not moving. So what would we call the energy in objects that are indeed moving? Well, scientists thought it was a good idea to call this kinetic energy. So why did I say earlier that kinetic energy is more interesting? Well, I just think moving things are more interesting than things that are standing still. Nothing wrong with that. So kinetic energy is dependent on two things. Unlike potential energy, where we need to calculate the weight and the height, kinetic energy depends on the mass of an object and also the velocity of an object. So more massive objects traveling at a higher velocity or a higher rate of speed are going to have a greater kinetic energy. So let me give you guys an easy example. If something had a mass of like a car that's very massive, and if a car was traveling down the highway very fast, that would cause it to have high kinetic energy. However, something with a very low mass, such as a feather, if it was fluttering to the ground very softly, a moving feather would have very low kinetic energy. So huge, massive things going fast have high kinetic energy. Simple enough. Now, what scientists did and physicists is they said, you know what? Since kinetic energy is pretty much dependent on different things than potential energy, we probably need to use a new formula. So the formula that they came up with for kinetic energy is this: 1/2 times the mass of the object times its velocity, how fast is it going, squared. So let's go ahead and take a look at an example. Say that, I don't know, what can my example be? A dude running across the street or something. So the first thing we do is we take 1/2 because that's the constant, we always need that. After that, you multiply it by the mass of an object. Now, the mass of me is probably 60 kilograms or somewhere around that. Now, say that I was traveling at a rate of 23 meters per second. Well, in order to calculate my kinetic energy, first, make sure you square the last number, and I'm just going to go ahead and throw out my units because units are kind of messy to work with. 1/2 times 60 times 23 squared. Now, I'm not going to treat you guys like idiots. I know that you know how to square this number and multiply already, so I'm just going to jump to the answer. If you want to, figure this out all out on a calculator or in your brain, you can. But the answer to this is 15,870, if I can write it, joules. Now, again, like I said, just like potential energy, kinetic energy is also measured in joules. However, a cool thing, since we're working with big numbers and in science, you can also write it like this: 15.87 kilojoules. That's supposed to be a lowercase k kilojoules. Whatever way you want, it's just two different variations of writing the same number. So that's basically the heart of this tutorial. Kinetic energy equals moving energy. Potential energy equals energy stored in objects when they aren't moving at all. So in the next tutorial, we're going to talk about the law of conservation of energy, which is one of the coolest and most interesting topics. I say that a lot, but this one really is. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video.